Hello and a warm welcome. This is Mr. T. As always, I hope I find you well. Thank you for tuning in. In today's video, we're going to be looking at the grade 12 aspect covering the arithmetic series. And it's important that you revisit, watch again the video on arithmetic sequence. It's going to help you in this video edition. Without any waste of time, let's get straight into it. Determine the sum of the series 2 plus 5 plus 8 plus up to 20 terms. Important to realize that your A is 2 and the common difference, you're going to get 3. Then state your values of A is equals to 2, your D is equals to 3, your N is equals to 20, and obviously your S20 is your unknown. So we're looking for the sum of the first 20 terms. So we're going to use the formula for the arithmetic series given by Sn is equals to n over 2 into 2a plus n minus 1d, representing the sum of our series. Thereafter, we're just going to substitute the values that we have stated above. We're going to get S20 is equals to 20 over 2 into 2 times 2, and our common difference is 3. It's a case of just substituting there, quite easy. We proceed and simplify. We're going to get 10 times 61, simplifying that we get the S20 to be 610. So the sum of these first 20 terms will give us 610. We proceed to the next question. The next question says, determine 3 plus 7 plus 11 plus up to 59. Important to realize that we are given the last term, which represents our Tn. So that 59 represents our Tn, our last term. Your A is 3, your D is 4, your N is unknown. We're looking for N. Our Tn as stated is 59. And obviously our Sn is also unknown. So we've got two unknowns here. Our N is unknown and our Sn is unknown. But what do we need to do? We're going to start by finding the value of N using the Tn formula. So we state Tn is equals to A plus N minus 1D. Thereafter, we're going to sub in our Tn, which is 59. So we're going to have 59 is equals to 3 plus N minus 1. Our D is 4. Simplifying that, we get 59 is equals to 3 plus 4N minus 4. Further simplifying that, we get 60 is equals to 4N. And again, if we solve for N there, we're going to get N is equals to 15. So we're working with 15 terms in this series. But we haven't fully answered the question. We want to find the sum of that series. So we're going to now use the Sn formula. But fortunately, we are given our last term to be 59. Therefore, I can use the shorter version of this formula. Sn is equals to n over 2a plus L. Your L representing the last term. So we can have it as 15 over 2. Our A is 3. Our last term is 59. It's just a case of substituting there. Then simplifying, we get our S15 to be equal to 465. So it's 465. If you add those 15 terms, our total sum should be 465. We proceed. The last question is saying, how many terms of the series 1 plus 4 plus 7 up to whatever must be added to give us 145? So we're looking at adding the sums of that series, which should total 145. That 145 represents your Sn. So we state our values. A is equals to 1. Our D is equals to 3. Our Sn is equals to 145. But what are we looking for? We are looking for N. So N is our unknown. Pretty much simple. We're going to use our Sn formula. So we're going to have Sn is equals to N over 2 into 2a plus N minus 1, close bracket D. Thereafter, it's a case of substituting what we know. So our Sn is 145. N over 2, 2 times 1, N minus 1, our D is 3. Then I'm going to multiply both sides by 2 to get 290 is equals to N, then open bracket 2 plus 3 minus 3, 3N minus 3. Then simplifying that further, I'm going to standardize that. I'm going to get 2N is equals to N, then 3N minus 1. Then immediately I want to standardize it and remove brackets at the same time. So I'll get 0 is equals to 3n squared minus n minus 290. Thereafter, you factorize, you get 3n plus 29 as a first factor. The second factor is n minus 10. Solving for n, we're going to get n is equals to negative 29 over 3, or n is equals to 10. But our n cannot be a negative, it cannot be a fraction. Therefore, we reject the negative 29 over 3 and only accept that our n terms, the number of terms, are 10 terms. So our n is equivalent to 10. I hope you enjoyed. Look out for the next video where we're going to be looking at a geometric series. Enjoy.